Good morning to everyone.
Good morning, ma'am.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning to all. So in the previous turn, we have started the discussion about the raster data. In that one, we have first of all seen the georeferencing. Okay. So as you must all remember that when we perform the scanning operation, we get a digital copy of any of the paper map. But that digital copy does not contain the map coordinate. It basically contains the scanner coordinates. For that purpose, what we need to do, we need to formulate certain function through which if we input the x and y of the scanned data, we will get corresponding latitude and longitude or northing and easting value of the map. Isn't it? So this is what the whole purpose of doing the georeferencing, so that our map, the scanned image, whatever we have, okay, it will have the map coordinate system. It is means it is a multiple step procedure. The first thing is we have to decide which type of polynomial distortion function that we are going to select. Okay. There are several options over there. Among them, affine transformation is usually taken. Like for the map purpose, we go ahead with the affine transformation. All of you write down the affine transformation equation in your copy. Quickly write the affine transformation equation in your copy and also give the meaning of every notation. It is necessary to remember these equations. So what is the affine transformation? As you can see on the screen, this one is the affine transformation formula where easting or longitude is equal to TE plus A1x plus A2y and northing or latitude is equal to TN plus B1x plus B2y. In this whole equation, what we want, if we input the value of x and y, we would get the corresponding E and N value. For that purpose, what is required? If all this TE, TN, A1, A2, B1, B2 are known, only then we can compute the E and N corresponding to given x and y. For this purpose, what we use? We use control points. Okay, we mark control points on the map. For each control point, there will be one value of E, one value of N, one value of X, and one value of Y. Basically, it will create two equations. One control point equal to two equation. If you mark three control point, three equations will be formed. There are, six equations will be formed. There are six unknowns. Six equation will help to solve the value of each of the six unknown parameters. In this equation, TE and TN corresponds to translation, means shift in origin. A1 and B2 corresponds to scaling in X and scaling in Y. A2 and B1 corresponds to the rotation in X and Y. So once you have marked the control points, you can think of it like this way. Okay. So in this one, you have to mark the control points. So once the control points are marked, the unknown parameters can be calculated. When you mark the fourth control point, automatically the error will get computed because there will be two set of values, one which is marked by you and another one which is computed by the software by using the affine transformation. The whole thing was demonstrated earlier, so hope everyone remember that thing. In affine transformation, we never mark minimum number of point, although with the help of three GCPs, six equation will be formed and the unknown parameter could get computed. But the problem is we cannot calculate the residual error. Okay. Therefore, we mark more than 3 points, and for that we got this error equation. Okay, so whenever you mark a point, there will be two types of error that will be computed. One is individually for each GCP, which is known as the residual error. Residual error is basically a distance between the marked point and the computed point. Ideally, the residual error must be zero, but it is not possible to have a zero residual error. So we try to reduce the error as far as possible. We try for the smallest value of the residual error. Whenever a control point give a very high residual error, we delete that point and mark the control point again. Once the residual errors are computed, RMSE error, root mean square error, is computed for the whole georeferencing procedure by the formula given over here. Once the fine transformation is done, for every pixel, for every cell of the raster data, the latitude, longitude or northern easting value is computed. So basically there will be an interpolation of all the points. Thereafter, there is a process of resampling. Why do we perform resampling? Because whenever this whole affine transformation is done, the original position may get shifted because of translation, because of rotation, because of scaling. The pixel will not be at the original position. So since there is a change in the orientation and size of a pixel, corresponding to new position, there will be no value. Therefore, we use resampling technique. There are three resampling technique: nearest neighbor, bilinear interpolation, cubic convolution, and nearest neighbor single cell is considered, which is nearest to the given pixel or cell. In bilinear interpolation, nearby 4 pixels are considered, and in cubic convolution, nearby 16 pixels are considered, and based on them, the new computed value is obtained. In general, we go for the nearest neighbor resampling. Why? Because it will give the original value. Like suppose there is any pixel which is located at the boundary of two different land use, like suppose sand and water. So both will have a very different set of values. And when you perform the averaging by using 4 or 16 pixels, some hybrid value will get generated. So generally we go for the nearest neighbor resampling technique. Thereafter, there were some questions that you need to compute the fourth point and other things. Then we have seen the place names. Okay, so the informal way of telling the location is by using the place name. The dictionaries that contains the place names are called the gazetteers. In gazetteer, you will find the place name and the corresponding location as given in this example, that there will be a place name, its type will be given, its location means its extent will be given in the gazetteer. Then there is a geocoding. Geocoding is a very useful tool. It's used a lot whenever we need to estimate any location. Why do we need to estimate any location, any address? Basically, because it is not always possible to gather the exact location. I have given you the example of fire station in the previous 10, that if there is fire and there is some victim and there is any distress call, so how a person will tell his location? By using the address. Okay. So by giving the address that this one is my address, there is a need to convert that address in the lat long value so that the help could reach to those persons. For that purpose, we use geocoding. So geocoding is like an estimation of a location with the help of the address. Geocoding is possible if you have a well-planned structure, like there is a well-planned street and streets. In that case, the starting point, the end point of the street is given, the addresses which are located on that street will be given. So the location will get estimated. This is an important thing to remember, that geocoding will not give you the exact location. It is estimating the location. Therefore, sometimes there will be an error in the location, but it will be near to that one. So this is what the geocoding Thereafter, we have learned raster data editing, that there can be different editing functions that could be done over here. Then we have started the analysis. In this one, the very first one that we have discussed in the previous 10 was reclassification. Okay, so what was reclassification? Anyone? Let's check. Abhijit?
Yes, ma'am.
Yes, Abhijit, what is resampling? Sorry, reclassification. Okay, so you are not giving the answer, then I am assuming that you do not know what is reclassification. Okay, the next, Alok.
मैम जैसे रीसैम्पल में अगर हमें एक पर्टिकुलर डेटा से कुछ केवल एक स्पेसिफिक डेटा चाहिए
No,
तो हम
don't get confused between resampling and reclassification. Both are different things. Okay, I am asking about the reclassification. The resampling thing is already explained. What is reclassification? Do you know the answer, Alok?
नो मैम
Next, Alok Ranjan.
Yes, ma'am.
What is reclassification?
मैम पिछली 2 प्रीवियस क्लास छूट गई थी मेरी मैम अभी।
Okay, next, Arun. Arun, what is reclassification? Arun, are you there? Next, Krishna Kumar. Yes, Krishna Kumar. Krishna Kumar.
Ma'am. Hello. Yes, ma'am.
What is reclassification?
Ma'am, reclassification assigning new location like new latitude and longitude to any given address or location.
So I'm not getting how are you giving this definition for the reclassification? New latitude and new longitude is
Like
reclassification.
Ma'am, it's Arun.
Yes, Arun.
Ma'am, actually I have some network issue, so can I answer now?
Okay, wait for a minute. Yes, Krishna Kumar.
yes, ma'am.
कौन सा आप बता रहे हो भाई? रिक्लासिफिकेशन में नया लैटिट्यूड लॉन्गिट्यूड कहाँ देते हैं?
Ma'am, sorry, ma'am, I didn't know.
पता नहीं होना ये तो एक अलग चीज है, लेकिन मतलब आप मुझे नहीं पता आप क्या बता रहे हो। शायद आप जियो रेफरेंसिंग बता रहे हो कि पता नहीं क्या बता रहे हो। चलिए, नेक्स्ट अरुण।
Yes, ma'am. Ma'am, it is a process of reassigning one or more values in raster dataset to obtain the new output.
कैन यू एक्सप्लेन इट विद द हेल्प ऑफ एन एग्जांपल?
मैम जैसे भी आपने बताया था कि जैसे रिसीडुअल एरर मैम आपने बताया था कि उसमें जब एरर ज़्यादा जाती है मैम तो उसको फिर हम नया पॉइंट लेते हैं। तो मैम इसी तरह हम एरर को मिनिमाइज करने के लिए हम रिक्लासिफिकेशन करते हैं मैम।
और ये कौन पढ़ाता है आप लोग को? ये सारा कंटेंट मुझे लगता नहीं आप मेरे क्लास करके आप लोग आते हैं। पता नहीं क्या बता रहे हैं। कहाँ से एरर आ गई? रिक्लासिफिकेशन में एरर कैसे आ गई? ये कब आपने पढ़ा कि रिक्लासिफिकेशन में एरर आ जाती है, उसको कम किया जाता है?
मैम हेलो मैडम, मैम दिस इज नारहरी।
यस नरहरी, बताइए।
मैम reclassification can be done by table methods and ranges method मैम।
कैन यू गिव एनी एग्जांपल ऑफ रिक्लासिफिकेशन?
मतलब उसमें मतलब डाटा मतलब वो
मेघावत, आपकी आवाज नहीं आ रही है।
हाँ हेलो मैडम।
हाँ बताइए।
मैडम वो मतलब वहाँ पे मतलब पॉइंट्स असाइन करने के लिए मतलब ये रिक्लासिफिकेशन करते हैं मैम।
कहाँ पे पॉइंट असाइन करने के लिए?
रास्टर डाटा मैम।
रास्टर डेटा में कहाँ पॉइंट असाइन करना है आपको?
पता नहीं मैम ये तो।
तो बड़ा डाउट हो रहा है आप लोग का। तो मतलब क्वालिटी देखकर नहीं समझ में आ रहा मुझे कि आप लोग क्यों, कैसे, क्या पढ़ करके आ रहे हो। रिक्लासिफिकेशन नहीं बता रहे हो कुछ भी। चलो मुनिंदर, मुनिंदर कुमार।
यस मैम।
आप कोई एग्जांपल दे सकते हैं रिक्लासिफिकेशन का?
नो मैम।
प्रीवियस
मैम
क्लास?
मैम
मुनिंदर प्रीवियस क्लास में आए थे आप?
यस मैम।
तो फिर क्यों नहीं दे रहे हैं?
मैम एक्सप्लेन नहीं कर पाऊंगा।
तो फिर क्लास करने का कैसे फायदा होगा? आप जब एक्सप्लेन नहीं कर पाओगे तो लिखोगे कैसे? वाइवा होगा, रिटर्न होगा, सब कुछ होना है आपका। कैसे दोगे एग्जाम? कैसे पास करेंगे आप लोग? एक्सप्लेन नहीं कर पाने का मतलब है कि समझ ही नहीं आया इसलिए एक्सप्लेन नहीं कर पा रहे हैं, है कि नहीं? चलिए नेक्स्ट, पारुल। यस पारुल।
Okay. Ma'am, reclassification is a process of reassigning one or more values to a raster data. Ma'am, for example, we are dealing with a vegetation dynamics of a region. तो मैम इसमें क्या होगा कि हम कैटेगरी वाइज उसको रिक्लासिफाई करेंगे, जैसे कि हाई, लो, मैम वेरी डेंस, हाँ डेंस और मीडियम एंड लो। इस तरह हम कैटेगरी वाइज हम रिक्लासिफाई करते हैं एज पर अवर रिक्वायरमेंट और एप्लीकेशन। तो इस प्रोसेस को हम रिक्लासिफिकेशन कहते हैं। और मैम ये एक्चुअली इसलिए किया जाता है ताकि जो हमारा जो डेटा सेट है वो सुटेबल हो जाए और इंफॉर्मेशन मैक्सिमम एक्सट्रैक्ट करने के लिए हम रिक्लासिफिकेशन करते हैं।
ओके ओके पारुल, करेक्ट। मैं पहले तो रिकॉर्डिंग स्टॉप करती हूँ।